Hey guys, this is Professor Janacek. I want to talk about power series. A power series about the value a looks like the sum as k goes from 0 to infinity of c sub k times x minus a to the k. That is a series. Again, it looks like an infinite summation. A few vocabulary words that go along with power series. The center is that value a. You'll notice this value here is our center. The coefficients are the c sub k's. Again, those are the values in front, just like a coefficient should be. And this happens to be a function of x. In fact, it's an infinite polynomial function, which is very handy that we can treat this like a polynomial. Even though it is infinite, it still is a lot like a polynomial function in many ways. The radius of convergence is considered to be the value r, such that if the absolute value of x minus a is less than r, then the series converges. If the absolute value of x minus a is greater than r, then the series diverges. Now, if that distance between x and a, that is the absolute value of x minus a, is equal to r, we don't know. It may or may not converge. We'll have to test those. Now we can build an interval of convergence off of this radius. So all we're going to do is we're going to take our center and we're going to subtract and add the amount of that radius. Sort of like the idea behind a circle. So if the series converges, that interval of convergence is a minus r, comma a plus r. Notice this is an interval. This is not an ordered pair, but we simply subtract and add the radius of convergence from our center. If we're looking at divergence, though, we're going to look outside of this interval. So it's going to be the interval from negative infinity up to a minus r, union with going from a plus r to infinity. Again, we don't know about the endpoints. We may have to include those. We may not. We'll have to test those independently. So some of those parentheses could turn into brackets. Let's try an example. Let's determine the radius of convergence and the interval of convergence for the sum as k goes from 1 to infinity of negative 1 to the k times x minus 2 to the k over 4 raised to the k. First thing I want to point out is that the center of this particular series is 2, and the coefficients look like negative 1 over 4 raised to the k. You'll notice the coefficients are in front of this x minus 2 to the k portion. The rest of it is the coefficient. All right, so we're going to have to remember our convergence test. I noticed that I do have an alternating series, but I also noticed that my k is only in an exponent. With k only in the exponent, I think the root test is a good one to use. If you remember how this works, we're going to take the limit as k goes to infinity of the kth root of the absolute value of our terms. Well, having a k in the exponent and in the index makes life easy. We can simplify this, and we can clear out that radical along with all of those exponents. This is the beauty of the root test. Now we can easily take the limit of this. You'll notice I don't have any k's inside my terms now. So I can simply take the limit. We get the limit of, we get the absolute value of negative 1 times x minus 2 over 4. I can take the absolute value of this. At least I could take the absolute value of parts. I could take the absolute value of negative 1 and of 4. So we end up with the absolute value of x minus 2 over 4. And if you remember the root test, this series converges as long as that limit, which we simplified down to the absolute value of x minus 2 over 4, as long as that value is less than 1. Of course, we can clear the fraction on that and get that this converges for the absolute value of x minus 2 less than 4. Thus, the radius of convergence if you take a look at what this looks like compared to my radius of convergence format, then we know that the radius of convergence is r equal to 4. All right, now let's see if we can use this to determine the interval of convergence. Well, if the radius of convergence is 4, basing it off of the absolute value of x minus 2 less than 4, remember what that means. I can actually rewrite that as negative 4 is less than x minus 2, which is less than 4. Again, that's directly off of this inequality with an absolute value. Of course, I can also kind of isolate the x there in the center, and we end up with negative 2 is less than x, which is less than 6. And that is looking a lot like an interval. Only thing we need to know is what happens at those endpoints. Remember, we don't know if those endpoints are going to be included or not. So we have to check convergence specifically at the endpoints. All right, so let's start with the endpoint negative 2. If we take a look at our series with x equal to negative 2, we have negative 1 to the k times negative 2 minus 2 to the k over 4 to the k. You'll notice all I'm doing is replacing x with negative 2. We can definitely simplify this, combine some terms. And combine a few more things. Reduce. Looks like we have the sum as k goes from 1 to infinity of just the series 1. Very simple series to work with. I think I'll just dive straight in with this one on using the divergence test. Remember, for the divergence test, all I need to do is take the limit as k goes to infinity of our sequence. In this case, it is equal to 1, which is not 0, which means that this diverges at x equal to negative 2. Remember, the divergence test can only tell me divergence, it cannot tell me convergence. But that worked out. This one diverged, no problem. So I think in this case, it diverges at negative 2, so we will exclude that negative 2 value. All right, that was one endpoint. Let's try the other endpoint at 6. First thing I'm going to do is simply rewrite my series using 6 in there for x. Again, we can simplify this a bit before looking at how this converges or diverges. Reduce some stuff and we end up with just the series being negative 1 to the k. Well, recognize this one as alternating So we'll use the alternating series test. Also a pretty simple test to work with. I'm simply going to take the limit as k goes to infinity of everything that comes after the alternating. So remember that this actually has a -1 after the alternating portion. So I'm just going to take the limit as k goes to 1, which we know is equal to 1, which is not equal to 0. And so by the alternating series test, this also diverges. Which means we will also exclude that x value of 6. And I think we've got it. So I'm going to take my interval. So here was my original interval, and then I'm going to add on what I just learned about the endpoints. Doesn't really change it much in this case. The interval of convergence. Goes from -2 to +6, excluding those endpoints. So it's just from -2 to 6. And there you go. Enjoy!